Well, all right. So at this point, in terms of using ordinary truth tables to determine if arguments are valid or invalid, of course, we've seen a couple of examples where the arguments turn out to be invalid, and we might be wondering, well, what happens, what does it look like when they turn out to be valid? And to illustrate that then, of course, what you want to be doing is working on a lot of the exercises from 5.4, specifically that first set of exercises, then the second one. I just want to work with you on the problem number 2 from the first set of exercises, which first of all asks you to translate the argument into the symbols of propositional logic and then use ordinary truth tables to determine if it's valid or invalid. And so that argument reads, Argentina has a huge foreign debt, therefore, sorry, Brazil has a, okay, I'll just start over here. Brazil has a huge foreign debt, therefore Brazil or Argentina has a huge foreign debt. So I misread it there. I'm trying to do it from memory, obviously. But that's the problem. Brazil has a huge foreign debt, therefore Brazil or Argentina has a huge foreign debt. And so we need to translate that first of all. And you definitely want to work on these problems when you're required to do these translations, like the word problems from 5.3 and all the way back to 5.2 and 5.1, because the translations, I would say, is really the most difficult thing you will encounter on the next exam. Nonetheless, the premise here, the very first statement, Brazil has a huge foreign debt, is simply B, right? It's a short affirmative statement, Brazil has a huge foreign debt. That's our premise. It's going to be separated from the conclusion by this double slash, and the conclusion says, therefore, Brazil or Argentina has a huge foreign debt. So, this is a fairly short argument here. We have B and we have A as our two letters. And so, with two different letters, we're talking about 2 to the second power, in other words, 4 rows. True, true, false, false for B, and true, false, for A, right? Your standard 4-row truth table, their standard pool of values. And by the way, right, if you're nervous at all about recreating this pool of values, if you don't really like exponents, of course, that's fine. Just remember, for the exam, you will do a 4-row truth table. You probably more than one, let's say that. But you will do 4-row truth tables. You will do 8-row truth tables. So just put this on your note sheet, so you don't have to remember the exponent, the formula. You'll know the pool of values that you need to write down for any ordinary truth tables like this. Nonetheless, here we go. We're going to go ahead and identify the main operator columns, in this case, B itself, and then the wedge. And again, I know it seems obvious as to what the main operators are here, but even so, you always need to identify the main operator column for all of the problems on the next exam, so be sure to get in the habit of doing that. Once we have this, of course, we have B is true, true, false, false, true, true, false, false, and then A, true, false, true, false. So there's nothing left to do here for the premise. And obviously, I didn't start in the conclusion here as I recommended earlier, but that's simply because for a problem this short, it's almost more work to think of how we might take a shortcut than it would be just to plug all the T's and F's in. So we get true wedge true is true. True wedge false is true. False wedge true is true. Remember, anytime there's true fitting into the wedge, it's true. And then false wedge false, of course, is the one way to make it false. And so we've got the main operator columns for all of the premises, just the one, and the conclusion. Now we look for all true premises and a false conclusion. No. All true premises? Nope. Not even a true premise there, so we don't really even need to bother looking at the conclusion in the 3rd row. And the same thing applies to the 4th row. And so obviously here, there is no row where we get all true premises and a false conclusion. And so we can declare this a valid argument. And this is what you would do to show that it's valid. You would show these main operator columns. You would show all of this work, really, and then you declare it valid. You don't point at any particular row because, in fact, it's the whole ordinary truth table that shows that it's a valid argument, right? So many more exercises there for you to work on from 5.4, and you definitely want to do that, especially those ones that require you to translate first so that you can get prepared for the next exam.